Assalamualaikum warahmatullahi wabarakatuh. My name is Ryan binti Maisuf. I am representing my group members to present our innovations entitled Application of Anisotropic Rod Deformation System Integrating the Mobilized Shear Strength. My group members are IR Nur Faizah binti Hamzah and also Professor Madya Muhammad Jamaluddin bin Muhammad Nur, and we are from Faculty of Civil Engineering. The originality of our innovations is to first to incorporate the strength in characterizing the rod deformation, and it can be derived from the stress strain behavior curve. As you can see from the graph, it shows that with the increasing of the deviated stress, they're increasing also in a axial strain. And our originality is utilize the raw anisotropic behavior, which is we can find through in situ or field stress condition, and it can be considered the true elastic plastic rock behavior. You can see from the graph here, it shows on how the true elastic plastic rock behavior. And the unloading curve prove that the rock is not elastic material and the rock has exhibit the elastic plastic behavior. The applicability of our innovations, actually the damage or a failure of a faulted rod slope is quite difficult problem in geotechnical engineering. And under static loading such as gravity or engineering building, the rock materials within a certain zone behind the tip of a crack or fault will behave strain softening property due to the action of stress erosions or chemical erosions. And by Muhammad et al. In 2008, it proved that the unnatural characteristics of rock engineering in comparison with the fresh rock due to the fresh rock to the residual soil. And this unusual behavior sometimes cannot be explained by the geotechnical engineers since its occurrence have been assumed roughly. And these inherent properties of the rock are established by applications of loading. Thus, the rock may fail as it reaches the monolithic failure stress, such as it could reduce the stability of the geomaterials and also the excavation boundaries, which can lead to a failure, which poses a significant hazard. So as we can see from the figure here, when we do the building, we construct building, there are possibility that settlement will occur. So this is we need to check uh, on the settlement at the rock. And actually, this shear strength envelope, it describes the behavior of rock when subjected to common stresses in construction, such as a compressive, triaxial, and also tensile stresses. And these shear strength envelopes are specifically for shale, which is a sedimentary rock which obtained from a dam project site in Baram. This has been conducted and it has been approved that we can get the settlement at the rock. And application of anisotropic rod deformation system integrating the mobilized shear strength innovation is completed and is successful. And this is a framework of methodology. We start from the literature review, and also we do a few device method in conducting the study, from preparing the rock samples that we take from Baram. The rock sample is shale until we conduct the test and validate the program with the laboratory results. And there are a series of triaxial compression tests were carried out to obtain the strength envelope of the rock sample. And for the verification of failure behavior, the uniaxial compression and were also conducted on the shale sample. From a triaxial test, a stress strain curve is produced. And the developed mobilized shear strength envelope within the specimen during the application of the deviated stress is interpreted from the stress strain curve. And these mobilized shear strength are used to predict the stress strain relationship at any confining pressure. And the predicted stress strain curve are compared against the curve obtained from the test. And these results show close prediction to the triaxial stress strain behavior from laboratory testing at the triaxial compression. And there are a lot of potential for commercialization for our innovation, which training, we can do a training manual calculation, and also we can also develop software application. And this application of this anisotropic rock deformation behavior of shale that obtained from a dam project in Baram, Sarawak, is instead of the common conventional 1D deformation consideration. And this can be used to replicate the true volume change behavior in rock so that the true foundation settlement in rock can be quantified. And this is the first innovation actually that can get the true foundation settlement in a rock. And this actual stress condition of the rock is anisotropic stress condition where the rock mass is subjected to the different confining and also from the vertical pressure. So as we can see from the graph and also from the table here, we can see that the geotechnical engineers can use these parameters in design of the foundation because it's already proof. It's already proof. And besides foundation, we also can use to design for underground structures and also tunneling excavation. And these are a few awards that we already received. Uh, one of them is we get the gold medal for product entitled A Compressive Soil Settlement Theory in UITM Innovation and Design during March 2008, which organized by Institute of Research Development and also Commercialization, IRDC UITM. We also got a gold medal for this product. For the product entitled Ultimate Soil Settlement Model in IIDEX International Invention, Innovation and Technology Exhibition during May 2008 at Kuala Lumpur Convention Centre. We also got gold medal for product entitled Ultimate Soil Settlement Model during the 60th International Trade Fair, Jena 30th October until 2nd November 2008 at Germany. And lastly, the latest competition that we have entered is IIDEX 2008. We only got a bronze medal for the product and anisotropic deformation model of Hawkesbury sandstone incorporating development of mobilization strength. So we believe that these innovations is very good enough and can go further because it's already a proof that we can get the true settlement at the rock. So that's all from me. I think that's all. So thank you.